Hello, everyone. On behalf of the Graduate Program Economics from the Federal University of Rio de Janeiro, I'd like to welcome you to the second event of our webinar series 2020. You know that our program is organizing this series with the aim to hold our academic community together during these difficult times of social isolation and lockdowns. We are committed to promote plurality in economics and discuss here frontier research in the general areas of macroeconomics, innovation, trade and industry, and economic development. You all know that we are expecting to have the annual workshop on demand-led growth in July this year. So that plan was frustrated by the current situation, which is now particularly troublesome in Brazil. We use this space here at YouTube, among other things, to emulate some of the debates that we would have in the workshop. And today we are glad to have Professor Steven Fazzari from the Washington University in St. Louis presenting the paper Implications for Fiscal Policies of Demand-Led Growth, the supply side. I'd like to thank you very much, Professor Fazzari, for accepting this invitation. I know the environment is not the very same of the workshop in Rio, especially the beer in Copacabana Beach, but I hope we can have a nice discussion today. And before we start, I'd just like to say a couple of words for the general people who are watching us. Please, you can drop a question in the chat of the YouTube chat. If you feel more comfortable to make your question in Portuguese, there's no problem. I'll do my best to translate it. And for our students, please do not forget to answer our questionnaire. We want to hear about some ideas that we are debating for this webinar series, and we have a couple of questions that we'd like to ask you today. So, Professor Fazzari, the floor is yours, or better, the spotlight is yours here. Thank you very much.
Thank you, Norberto. It's very nice to be with you. Yes, I very much missed the July trip to Copacabana. It's a beautiful place. I know that what's happening in your country right now is challenging. I understand it. I, in some ways, could see it coming when you saw the infections rising in the U.S. and could see it spreading. And having been there and seen some of the challenges you face, especially in Rio de Janeiro, I very much sympathize you and think about you all regularly. I hope all my friends there, old friends and new friends, are okay and will stay okay. Thinking about you, very, very fondly. Also, just to note the kind of cultural connection, this is an interesting day in the United States. Today is what is becoming a holiday. It's called Juneteenth, a very strange name. Maybe people have not heard of it, but it's recognizing the day that slavery actually ended in the United States, which is actually later than the Civil War because of some historical details. But it's become, in the context of things happening, in particular, issues with race and discrimination and inequality, has become an important day. And so I wanted to recognize that as well, speaking with you at this time. So I am going to try to switch over to the slides and get down to work here. There we go. I see you're looking at the slides, so I think everything is working okay with the technology. We had a few glitches, but here we go. So I'm very happy to talk with you about this research. It's really a combination of two different papers. The first one is about the linkage between demand-led growth and the supply side, which is the focus of a paper that just came out, I think, about 2 months ago in the Cambridge Journal of Economics. And I think I distributed a PDF in advance of the seminar. So I'm going to start by summarizing some of the key results there. This is work that many of you have heard me present in Brazil before. I've given it in a number of different places. So I'll kind of summarize there. I'm happy to say, even though I'm sometimes slow with my research, that my co-author Piero Ferri and I have been able to extend this work into talking about fiscal policy. And so I'm excited to share some what I think are really interesting results with you about this new research. So let me just start with some acknowledgments. Of course, this work, all this whole research program I'll be talking about is co-authored with my longtime friend from the University of Bergamo in Italy, Piero Ferri. It's also based on earlier work with close co-authors, Anna Maria Variato in Bergamo, and my late colleague, Edward Greenberg, here at Washington University. I'm always grateful to the new Institute for New Economic Thinking for broad financial support in these things, and should also mention the Forum for Macroeconomics and Macroeconomic Policy, where I'm a fellow in Berlin. It's been very helpful. So let me start off with just some broad comments about Keynesian macroeconomics. I know there are a lot of students in the audience, and hopefully this won't be redundant. But this is where I see my own location as a macroeconomist as being, sometimes I call it an unapologetic Keynesian in the context of the developments of macro, mainstream macro, especially here in the United States, where at times being a Keynesian was considered a rather negative thing. But I've always been proud and happy with my Keynesian roots, which always seemed to me mostly realistic, with the basic message being that demand drives production and employment. That more spending, we get more output, more production. When firms sell more output, they hire more workers. There's really little doubt about this empirical relevance. Right now, we're in this very unusual pandemic-forced shutdown of the economy. I've been thinking, is this really a demand shock, a supply shock? It's to some extent, it's somewhat both. At the moment I'm using this term, it's a forced demand shock. That is that people are being forced not to engage in their normal economic activities, and the result is that businesses are shutting down. The supply is falling in immediate response to this demand shock. This is a very unusual time in these first months of this crisis, but especially in the U.S. context, I'd say there's a rising fear of more conventional Keynesian demand weakness in the aftermath of the most immediate part of the health crisis. Things like falling business investment, the reluctance of consumers to start spending. If unemployment benefits are not extended, there are enhanced unemployment benefits in the US that are actually pretty generous, but if they're not extended beyond July 31st, we could have a big decline in demand from that perspective. State and local governments are constrained in the United States by balanced budget rules, and so their revenues are falling. A lot of their revenues come from sales taxes and income taxes that are plummeting. And so they're cutting back, leading to layoffs in the government sector and further demand weakness. So what had started off as a health crisis and a very unusual kind of coordinated demand and supply contraction may be moving to a more Keynesian demand-driven recession as we move forward. We'll see how that all plays out. So this is, this is broadly relevant. If you read any kind of practical analysis of economic activity these days, you'll see these very strong Keynesian perspectives there, even in what might be considered conservative publications like the Wall Street Journal. Everybody is thinking in demand-driven ways these days, at least in the short run. The bigger issue in some respects for the heterodox Keynesian message is that demand dynamics shape economic performance beyond the short run, that it matters for growth. It matters for growth over longer periods of time. This is a more contested view. It's harder to verify. And in particular, if you're thinking about demand-driven growth over a longer horizon, we have to integrate the supply side, it seems to me. There's a lot of interesting research in the heterodox Keynesian literature, the super multiplier models that have their home at your university, the Koleskian growth model, and things along these lines, which are important part of my own perspectives on economic research and what explains economic activity. But most of these models, I think it's fair to say, largely ignore the supply side. You'll have a simple statement along the lines of, well, assume that labor is an infinitely elastic supply or something like that. No limitations on supply or production. And it seems to me that this is a bit problematic in ways I'll talk about as we go forward. And so this is where we are headed. And let me start with just a brief history of what actually turns out to be a very long research program, but with a huge gap in it. And again, I apologize to those of you who heard me give this summary before, but I think especially for the students in the audience, you might be a little interested in where some of these ideas have come from. So I actually started working on this topic when I was writing my PhD dissertation under the well-known heterodox economist Donald Harris. And I was at Stanford at the time in the early 1980s when this work was really getting off the ground. And I was trying to understand, well, what drives the dynamics of production? What drives the employment? And my conclusion, based on what I felt was pretty strong intuition as well as some personal experience, is that the expectation of sales drives what businesses produce and the workers they employ. And I won't go through the details, but I kept writing down some models that were original from my point of view, and found myself rediscovering basically the Herod warranted rate of growth as a steady state path of sales expectation driven production, and along with that, the instability of that warranted path. And so my dissertation was to a large extent both a rediscovery, but also an interpretation of Herod. I published my first paper on this topic in 1984 in the Journal of Post-Keynesian Economics, and I can give folks a nudge to go back and look at that old paper, which summarizes it, not all, but a big part of the results in the dissertation. I always felt, though, that this was just a starting point, that there were certain aspects of the model was still basically Herod's model. So it had the knife edge property that if there was a positive shock starting at steady state, you'd run off to infinity, and a negative shock, you'd run down to zero, which doesn't adequately describe reality. And my hope was to get back and working on these things, but I was somewhat delayed, to say the least. And so didn't really get back to working on this until well after 2000 in ways. I kept thinking about it, but I really didn't publish or do anything. But Piero and I and Ed Greenberg started working on this topic again in the I don't know, around 2010 or so, and really wanted to address this instability condition. And our first intuition was, well, the ceiling is easy to understand. Basically, it is a supply constraint. At the end, you can't go off to infinity. You're going to eventually run out of resources. So supply limitations would limit the Herodian instability on the upside. It was more subtle to think about what turned the cycle on the downside. And I remember quite vividly sitting in a St. Louis summer, which is really quite warm often, under a tree outside, and thinking, if there was just some part of demand that didn't move with the business cycle or didn't move with output. So we have consumption collapsing because of a marginal propensity to consume. We have investment collapsing in a negative way because falling growth expectations. If there was some part of demand that could move independently of the state of the economy, then that could be the stabilizing factor. And of course, this is what is now well known as autonomous demand. And we put it into a formal model and came up with the result that really any small amount of autonomous demand in this basically Herodian framework would be adequate to turn the cycle on the downside. It would provide a floor effectively, not the kind of hard floor of say, a capacity ceiling, but a lower bound as to how far the business cycle could go, and wrote some simulation models and along with some simple mathematical proofs to verify this result. And so our first vision here was that the actual path of the economy could be locally unstable, but bouncing between the ceiling created by resource constraints and the floor that was the result of this even small amount of autonomous demand, which might be growing, might not be growing. And so that we just kind of see the economy bouncing around in this corridor. However, after building these models and running some simulations and trying different parameter configurations, I realized that it wasn't always unstable. It wasn't that just the economy was cyclically bouncing between the ceiling and the floor, that under some parameter configurations, indeed, the dynamics of what you might call the Herod's warranted rate of growth path were convergent, that we converged to a stable growth path and didn't bounce around between ceilings and floors, and started to explore the possibilities or what that steady state looked like, or what the characteristics of that steady state were, and indeed rediscovered Franklin Serrano's 1995 supermultiplier result. So for the second time in my career, I rediscovered Herod in early 1980s, and in around 2011, 12, rediscovered Franklin Serrano. So I felt like at least I was in good company. Would have been nice if I'd been, maybe a little more original there. But the thinking that led to this was actually independent of these authors' results in this context. And We published this paper in the Review of Keynesian Economics. In fact, I think it's the first volume, the first issue of ROKE in 2013. And in particular, with maybe a little more emphasis on this idea of Herodian instability bouncing between a ceiling and a floor, but recognizing the possibility of convergence to steady state, the link to the supermultiplier. In our recent paper, in our 2020 paper in the Cambridge Journal, this is really the supermultiplier model is the central part of what we're doing. We're coming at this in a variety of ways. Sorry, I've got to get my slides moving correctly. Here we go. So this is what encouraged the movement to start thinking harder about the supply side of these models. So in the Review of Keynesian Economics paper, the supply side ceiling is exogenous. It just comes from an externally imposed labor supply growth of physical number of hours or workers, and multiplied by an exogenous growth rate in productivity, all of which are independent of economic conditions. And this leads to three rather unappealing kinds of regimes. In one case, everyone at this university is familiar with the supermultiplier model. So demand growth in the long run is driven by autonomous demand growth. That is what drives the demand path, possibly with cyclical adjustment around it. So if autonomous demand growth is greater than supply growth, exogenous supply growth, then what's going to happen is you're just going to, move up and hit the ceiling and basically stay there until there's some kind of a negative demand shock or change that pushes you away from it. So you kind of get demand leading you to the ceiling at which you hit it, and there you stay. If autonomous demand growth is less than supply growth, then there's this unbounded rise in unemployment. You might converge to the demand-led path, but the supply path would diverge indefinitely. And then, of course, the third case is just a knife edge case where autonomous demand growth would actually equal supply growth, but there was no reason in this model why that should be true. In fact, a lot of the simulations we did, we just imposed that condition to get what looked like somewhat more interesting results, but there was no reason as a practical matter to assume that in the model we had in 2013, that autonomous demand growth would equal the supply growth. And so this was the motivation for the next step of our research program, which just came out in the Cambridge Journal, to make the supply side responsive to the state of the economy, to endogenize the supply side. So let me go through the model, relatively quickly, and then move on to some of the main results of the 2020 paper, and then talk about fiscal policy. So the slide that's up there right now just shows the basics of the model. A simple consumption function based on consumption. Everything is recursive in this model. So consumption in period T is based on expectations of income, starting from income in period T minus 1, multiplied by an expected growth rate. And then there's a propensity to save that reduces consumption relative to expected income. Investment is just the difference between the capital stock in period T plus 1 and the depreciation adjusted capital stock in period T. And then we generalize this very much in a Herodian kind of framework. So we have a fixed capital out. Well, let me talk about the capital output ratio there. There's a, let's call it a target capital output ratio determined as of period T that will be the target capital stock in period T plus 1. So the timing is you invest in period T, it determines capital in T plus 1. So there's just a bit of a question about what the subscript should be on the V hat term. But this is the target capital output ratio you're trying to attain in period T plus 1 that or you choose in period T. Again, expected growth matters. You want to have the output you anticipate for period T plus 1, hence the compounded square term here, and then subtract off depreciation. So this is the capital stock that you're targeting for period T plus 1, and this is the capital stock you have in period T adjusted for depreciation. Just want to make sure that my cursor is showing up here. I wonder if I could change that too. Well, I'm not going to try to mess with the technology here. I think you're seeing it okay. I hope so. Let me know if that's not the case. So this is investment, consumption and investment. This basically was my model from my 1984 or my 1982 PhD dissertation published in the JPKE in 1984. What we added in the 2013 paper was the autonomous demand component that was growing at some rate. So FT in this notation we used in this paper was just the autonomous demand growing at an exogenous growth rate G star, or I should say at least a given growth rate G star. And then output is equal to demand, which was consumption investment plus the autonomous demand component, without defining carefully what autonomous demand was in terms of, is it government spending? Is it exports? Is it debt finance consumption? Obviously these things are in the literature. Different authors have used different things. In our case, we just stayed rather general and said autonomous demand is what it is. In particular, we define it there as demand that's independent of the state of the economy, that doesn't depend on the actual level of output, YT. So this is really the 2013 model largely. As we move forward, we added some additional dynamics. This we actually had in 2013, which is an adaptive expectation specification for growth. I know that can be somewhat controversial in the mainstream literature. Adaptive expectations was largely criticized through much of my career in mainstream macroeconomics. But I think it makes a heck of a lot of sense. It basically says that expectations adjust in the direction of the most recent expectation error. So you get this basic kind of result. The alpha term is actually important for the dynamics of the model, the speed at which expectations adjust to the actual case. You can see that alpha is the weight on the previous period's expectations. And so a large alpha in this parameterization is generates some stability. And I wanted to recognize some of your colleagues, a nice working paper that Ricardo Suma sent me and with co-authors Haluska and Braga, finding that the alpha is actually quite large. That actually is consistent with the results in our paper. I might talk a little bit more about later. We did some empirical calibration here and estimated alpha to be around 0.9, so on an annual basis. So really somewhat slow adjustment of the kinds of expectations that we see, especially the longer term expectations relevant for capital accumulation decisions. And as I mentioned here on the slide, if you anchor those expectations with a relatively large alpha, that enhances the dynamic stability of the model. We also learned, and this was new in the 2020 paper for us. We did not have this in the Roque paper from Fabio Freitas and Franklin Serrano's very nice exposition of one of their supermultiplier models about having a slower adjustment of the target capital output ratio. So V star is the long run, technologically determined, if you like, capital output ratio. But what we found when we basically set lambda equal to 1, and which basically means the V hat term just became V star, so that firms were targeting their long run ratio every period, is that the dynamics tended to be extremely volatile. And this was actually true in the simulations of our Roque paper. It turns out that the specification that Fabio and Franklin have used really is I think much more appropriate, and again empirically supported. We did some estimation of the lambda term using US data on capital stocks, using various specifications that's in the appendix to the CJE paper, and found again lambda being far away from 1. In fact, again, I believe the number is 0.09, like around, again, somewhat similar to the alpha, although in this case a small lambda, let me see, yes, a small lambda is stabilizing. That kind of slows the adjustment process here. So that also enhances empirical stability of the model. So there's a few innovations there, in particular adding the Freitas-Serrano capital stock adjustment relative to our earlier paper. But the real contribution of the 2020 paper is the introduction of endogenous supply. So let me go through this in a little bit of detail. I'm just going to move this in my window here a little, so I'm looking more at you when I'm talking to you, and not off to the side of the slides. The first part of endogenous supply is linking the actual supply of labor, number of hours, number of workers, to the level of unemployment. So you see a very simple linear specification that the growth of labor supply is a negative function of the unemployment rate. Higher unemployment rate slows down the growth of the labor force. You can justify this in a variety of ways. Labor force participation, matching models suggest that when there's a kind of a higher probability of a good match that more people will search and go into the labor market. Immigration effects can be important, especially in a country like the U.S. prior to Donald Trump, where low unemployment rates encourage more immigrants to come into the country. There's a Phillips curve wage linkage, which would say that lower unemployment rates would raise wage growth, and higher wage growth would encourage more workers to enter the labor force. So a variety of ways to link this together. I want to emphasize, notice that this is the level of unemployment, so the kind of level or current state of the economy that links to the growth rate of labor supply. So you have this dimensional linkage between the level of economic activity and the growth of the supply side. That's going to be important in the model for reasons you'll see. I mentioned a few authors who have made these kinds of arguments before. John Cornwall and his daughter, Peter Scott, Mark Setterfield. There's some in the DeLong and Summers arguments about hysteresis, and I'm sure there are many others that we could talk about. Also, in terms of things that need to be explored going forward, I want to mention about nonlinearity in this. Our models are linear in these supply side things, but you certainly think nonlinearity would make sense here, that a fall in unemployment is going to induce some increase in labor supply. But as unemployment gets very low, you could imagine that effect getting smaller. And that's something that should be explored further. I have some intuition that suggests that basically these results are going to go through, but that's something we need to do more in further research. Part two of endogenous supply relates to labor productivity, where again, we're going to link productivity growth to the level of the economy through the unemployment rate. So again, high unemployment, lower productivity growth, stronger economy, low unemployment, higher productivity growth, but also to this growth term. So this is the growth of the capital stock plus the depreciation rate. You can think of this term in parentheses here as the turnover of the capital stock, the rate of capital turnover. So the idea here is that as you install new capital, you're going to be raising labor productivity, as well as with a stronger state of the economy. So there's two independent effects here in this productivity equation. This first one looks just like the labor force growth one, in the sense it's the relationship between the level of economic activity measured by the unemployment rate and the growth rate of productivity. The second term is a growth on growth relationship. This is basically a Verdurne's law effect, as it says on the slide lower down, that when the growth rate is higher, you'll get higher, the economy is higher, you get higher productivity growth. So we have both a level and a growth rate effect in this equation. Again, justifying this, I really like Amitava Dutt's phrase in one of his papers: necessity is the mother of invention. When the unemployment rate is low, workers are hard to find, you find ways to raise labor productivity. Learning by doing would be another long-term kind of reason for this. Technological dissemination through investment, that really justifies especially this other term, but you also have stronger investment when you have a stronger economy and lower unemployment rate. DeLong and Summers emphasize the idea of skill decay from high unemployment. So when unemployment's high, people out of work, their skills may go down, downward over time, lowering labor productivity. So there are a variety of different so-called micro foundations one could look at to justify this linkage here. I mentioned how it embodies the Verdurne's law effect, and that, of course, ties to Kaldor, some of the things John McCumbee has talked about over the years. Tom Pally has some interesting work here. Again, Mark Setterfield, DeLong and Summers. I'm sure I'm missing lots of authors that have talked about these issues, but there's a wide variety of literature, somewhat more extensive citations in the Cambridge paper. Okay, so this is the structure of the model: demand side, supply side. We put them together. What do we find? Well, no surprise, we get the standard supermultiplier result that demand growth happens at the rate of growth of autonomous demand, G star in our model. And then I've emphasized and underlined, bold-faced and underlined, the key result here in the paper: supply growth converges to demand growth. I mean, this is just, to me, a very exciting, important result. The idea that if the demand side of the economy is stronger over the medium to long run, that the supply side will converge to it. It basically reverses the basic Say's law story. This is demand creating its own supply rather than the other way around. Just to get a little intuition for this, it's reasonably straightforward why it happens. If demand growth is greater than supply growth, maybe you have started in steady state, you have some positive demand shock, or the growth rate of autonomous demand goes up. Demand growth is greater than supply growth, the unemployment rate is going to fall. lower unemployment rate will encourage faster labor force growth, faster productivity growth, so the supply side starts to catch up. If the model is dynamically stable, the demand growth path will converge to the supermultiplier path, growing at the steady state rate of G star, and supply will eventually catch up. So our simulations showed this when we were working this out in the various rounds of the rather slow referee process with the Cambridge Journal. One of the referees was nudging us to be a little more analytical about it. So I want to thank my mathematics colleague, John McCarthy. We linearized the model and did some eigenvalue calculations that are in the appendix. And John helped me prove that under the conditions that we have these rho one and theta one terms, these like this term right here, they're non-zero, that we will actually get convergence of the supply side to the demand side. So the result is, if the demand side is stable, if the demand side itself converges independent of supply, that supply will follow demand. So we get a demand-led growth path of both actual output and potential output. So this really opens the door to a much longer run perspective on how stronger demand can pull the supply side along with it. There's how does this work in some sense? Well, the convergence to the long run steady state involves, as I mentioned in the previous slide, adjustment of the unemployment rate. So there's a steady state unemployment rate, which is given here, and here you see the importance of these effects of the level of the economic activity on the growth rate of the supply side. The theta one and rho one terms, this is the effect of the unemployment rate in the labor force growth equation, and this is the effect of the unemployment rate in the productivity growth equation. And so we need the sum of these to be positive to have a well-defined steady state unemployment rate that generates, or when you reach it, generates the convergence of the supply side to the demand side. So this is a necessary condition for both the convergence and existence of the steady state unemployment rate. That's what our little proof in some sense shows that I mentioned before. The Verdurin effect matters. It shows up right here. It matters quantitatively, and I'll emphasize this in the next couple of slides, but it's not necessary for convergence from supply to demand. Even if the Verdurin effect of growth of the economy through investment tying to the growth rate of productivity, even if that were zero, we would still get the convergence of the supply side to the demand side. One thing that, in terms of getting beyond some of these technical results, is that there's no natural equilibrium unemployment rate that's independent of the demand path. I mean, you see it right here in the equation. Here's G star driving the demand path of the economy, and it's determining the long-run equilibrium unemployment rate. And so this idea, mainstream idea, going back to the Friedman-Phelps vertical Phillips curve idea, that there's a natural long-run rate of unemployment that's entirely supply-driven, is certainly not the case in our economy, or in our model, which is integrating the supply side in a fundamental way, but emphasizing the demand-led path. So this is, I think, a fundamental result of this work. There is, however, a resource limit to this argument. And before I even get into the details of the slide, let me just share a simple thought experiment. Sometimes I tell my undergraduate students, when we're talking about macroeconomics and Keynesian stimulus, I said, look, I'm talking about the U.S. economy. All right, the U.S. economy is it's now a little higher than that, but first approximation, a $20 trillion economy. If you tell me, if we put $1 trillion of stimulus, 5%, could the economy handle that? Could output rise by 5%? Maybe more than 5% with the multiplier? And the answer in my intuition is often yes, especially in recent years of secular stagnation. However, if we put a quadrillion dollars of stimulus into the U.S. economy, many orders of magnitude greater, clearly this could not be accommodated by the supply side. All you can think of is we'd have some kind of hyperinflation. So there is, in some sense, a limit on resources. And in fact, in this model, there is a very natural way to think about this, and it's to think about labor as a non-reproducible factor of production at some level. Now, endogenously, you can induce more people to work. You can induce them to put in more hours by having a stronger economy for the reasons I talked about a few slides ago. But there is going to be some minimum to how low unemployment can go. And if we impose a minimum constraint very simply on the unemployment rate of U hat, then we'll get a maximum supply growth, a supply growth that's here. So this is the G hat. It's different from the G star. It's the maximum growth rate that the economy can attain if the unemployment rate hits its minimum. And again, there's a lot of case for nonlinearity here and not thinking of this as a hard constraint, but here's a first cut at this. And here I want to emphasize a few things. One is, I may be not doing this quite the same order as the slide, but notice here this Verdurne's law effect is quite important here, that it wasn't necessary for convergence, but that it generates a quantitatively important effect on the G hat. And so a large Verdurne's law effect will raise the maximum growth rate that's possible from the supply, limits from the supply side. And actually, just again, a kind of interesting thought experiment. This is not empirically relevant, but you can see that this equation breaks down if rho 2 approaches 1. Well, what does a rho 2 of 1 mean? It means that the growth rate of the economy translate 1 for 1 into the growth rate of productivity. So if rho 2 is 1 or very close to 1, it does mean in some sense that you could grow at an arbitrarily high rate. I don't think it's very realistic empirically, but people do find quite substantial estimates from rho 2. I actually can't remember exactly what our benchmark number. I think it's around 0.5, and that's our own estimates, but it conforms well to what you see in the literature. So this is a very big effect on what could eventually be the constraints on the economy imposed by the supply side. There's I think generally here, I mean, I more or less said this. This result is reasonable. It's a result I actually like of the model in the sense that it is sensible that ultimately there are going to be resource constraints in an economy. To simply say that we could have demand-led growth without bound, I don't think anybody really believes that. But a lot of the models really, kind of gloss over that. In our case, it's explicit, and I think that's a benefit of where we're going. This is maybe just kind of a little bit of an obscure effect, but something I just thought about in putting these slides together and rethinking this. Notice where this depreciation term shows up here. It shows up as a positive effect on the maximum supply growth. And why is that? Well, it's because that productivity depends on capital turnover. So a high depreciation rate means you're turning over your capital stock faster. And one of the kind of stylized facts in capital research over the years, and people looking at that, and you see a bit of this in the data, is that with a higher technological component of capital, so more computers and things like that, that actually depreciation rates are higher and replacement rates are higher. And so, interestingly, that depreciation effect, other things equal, would suggest a higher maximum supply growth in recent years than we've actually seen. In fact, of course, what we've seen is, at least in the U.S., is slower growth, especially since the Great Recession, or since the peak before the Great Recession. And given this depreciation effect, there's a question of maybe we just don't have enough demand. That's something I can come back to later, that if anything, that maximum growth rate might actually be rising, not falling, during these recent decades in the U.S. I want to emphasize before leaving this slide, yes, there are limitations on accommodating supply, an upper limit, but there's a continuous range of growth paths that are consistent with supply and demand growth as long as G star is less than or equal to G hat. And I think this is where we are. And I think that indeed what we see is growth paths that could be better because demand is not as growing as quickly as it could be. And that's important for the policy implications as we go forward. A few more comments before I move on to fiscal policy. Just something about dynamic stability. And this is really important. And there's new work here. I've got it down on the bottom, but some of your colleagues here are actually have a nice paper in Metroeconomica, which I haven't fully digested yet. I just found out about it, but looked at quickly, emphasizing stability conditions for supermultiplier models. The work by other colleagues here, the empirical work, is finding that these stability conditions are actually satisfied empirically. That's largely our conclusion too. We have this calibration exercise in our model. I mean, theoretically, our model can be stable or unstable. It depends on parameter values, and results similar to what Serrano et al. Are finding in the recent Metroeconomica paper. But the empirical results suggest rather strong stability. So we created a very generous range of empirical parameters for the model, incorporating just about anything that it would be discussed in the literature, and then extended even further. Some things that I think are actually pretty far away from the direction of sensible in the destabilizing direction, but we included them and did this kind of massive simulation. I don't know, 120,000 some runs of the model, and found that in 75% of the cases, in this very broad range of empirical parameters, the model was stable. That is, it converged to the super multiplier growth path, and demand and supply converging along with it. And in my opinion, the more realistic parts of this parameter space are all very strongly stable. And a lot of this relies on these slow adjustment speeds for expectations and capital formation. If there are some questions along those lines going forward, maybe I should be checking that, actually looking at this to see where we are. Yeah, basically I see everything is okay. That's good. So glad to see that. Maybe I will kind of move along here, and hopefully there'll be time for maybe a general questions at the end through the chats. It's a little harder to do in real time. Anyway, so as I was saying, that the stability results, a lot of that comes from these relatively slow adjustment speeds, both for expectations and for the capital output ratio, which seem to be empirically quite strong. I mean, if you look at the U.S., again, not so much the quarter-to-quarter expectations, but the kind of expectations relevant for capital accumulation. The long-term expectations for growth change surprisingly slowly. We estimated our model from the data on the survey of professional forecasters, and the results are actually quite robust. I refer you to the appendix of the Cambridge paper for more information there. I will mention, though, that the convergence is slow. I'll actually show you some numbers when I put the fiscal policy stuff in. I'll show you some simulations. Convergence is actually quite slow. And so as a practical matter, the convergence to the super multiplier path is likely to be interrupted by all sorts of stuff. COVID-19 comes to mind right away, a housing bubble and a housing burst, which some people would argue had something to do, I would agree, with autonomous demand, but kinds of shorter term dynamics that are generating the more cyclical kinds of fluctuations that much of macroeconomics and Keynesian macroeconomics focuses on. So in this context, we might not see the steady state super multiplier path applying, certainly to quarter, or even sometimes to year fluctuations. They might be dominated by more short run dynamics. That said, I would I strongly defend the idea that this steady state, the super multiplier steady state, is a kind of center of gravity for the economy. And over medium to long periods of time, I think it's quite relevant. So if you're talking about why an economy might grow rather slowly, as the U.S. economy has since the peak before the Great Recession in 2006-7, depending on how you time things, that I think looking at these super multiplier kinds of dynamics are directly relevant to thinking about those issues. Okay, another result from the 2020 paper that I think is really important is a simple quantitative result. So I showed you the equation before for the equilibrium unemployment rate. The derivative of the equilibrium unemployment rate with respect to the growth rate of autonomous demand, so the long run growth rate of the economy at the center of gravity, is this expression right here. And so this all depends on these three key supply side parameters. I'm sorry, this equation's wrong. That should be a theta 1 down here. I made a mistake on that one. So it's the rho 2, the rho 1, and the theta 1. These are the ones that relate level of output, level of the economy, unemployment rate, to the growth rate of the supply side. And this is the Verdurins law effect, growth on growth. And if you put those, if you use the empirical parameters we calibrated, you get this derivative to be about 0.7. Now, what does that actually mean? Well, think about the thought experiment that you see on the slide. Suppose you had a 1 percentage point acceleration in demand growth. So G star rises from, say, 2% to 3%. Then what has to happen to make the supply side accommodate the demand side is a 0.7 percentage drop in the unemployment rate, which is an entirely plausible and reasonable number. And one of the ways I've motivated this result in other talks is to say, well, okay, so I'm telling you the supply side converges to the demand side, and the unemployment rate adjustment is the key parameter that makes that work. Well, if it took a 20% decline in the unemployment rate to accommodate a 1% increase in the growth rate, this result would not be really very interesting because it would be kind of implausible. You'd run into the lower bound limit on the unemployment rate all the time if you're trying to accelerate the economy. But it just doesn't seem to be the case. And even if this derivative was substantially, in this case, larger, maybe it was one, even a bit bigger than one, these kinds of, a 1% increase in the medium to long-term growth rate is a big deal. And if it required only a modest adjustment, well within the empirical range of what you might think is feasible of the unemployment rate, that makes all the results of this work much more economically relevant in my view. And of course, on the other side of it, slower autonomous demand growth always drags dynamic path of output and supply downward. And again, it won't show massive increases in the unemployment rate, but if it slows, according to these empirical results, if it slows the economy down, a weak demand path is going to bring productivity and labor force growth down with it. So this is kind of where I want to summarize the results from the 2020 paper and then move on for the rest of the talk into the fiscal policy results. So as I mentioned before, there are big differences from mainstream macro. There's a reverse Say's law. In the positive direction, we've got demand creating its own supply rather than supply creating its own demand. In the negative direction, a permanent demand decline, or maybe I should argue a persistent demand decline, never has temporary effects on output and employment. It's always going to have a permanent effect. It's going to change not only the level of output, but the level of potential output. The idea of demand shocks having a temporary effect on the economy with the supply side moving along independent demand is certainly contradicted by this model. There's what I've called this Luddite effect of a positive productivity shock. As those of you who know some British economic history would know, the Luddites in the Industrial Revolution smashed the textile weaving machines because they were afraid, correctly so from their point of view, that these machines would put them out of work. This kind of idea is often criticized in mainstream macro because say, well, if labor productivity rises, then we have endogenous wage and price adjustment, or maybe enlightened monetary policy that will take care of the demand side, and so we just get faster growth and higher wages, and everybody should be better off. In this model, that's certainly not obvious. That if the demand side is weaker, well, let me put it this way. Think about a little bit different thought experiment. Suppose that there's a positive productivity shock, but nothing done to stimulate the demand side. You're going to have faster growth on the supply side exogenously because of the positive productivity shock. That'll show up as one of those rho zero or theta zero terms in our model. But the unemployment rate, the equilibrium unemployment rate, is going to rise without further stimulus in demand. Actually, maybe it's worthwhile just showing that result formally. So I put this equation in here. So you get a positive productivity shock here. Other things equal, that raises the equilibrium unemployment rate. What you need to do is raise the growth of demand to offset that to make this work. And this is by no means automatic. So you can't just look at the supply side. You have to look at the demand side as well in thinking about medium to long-term growth. As I mentioned before, there's no natural rate of growth or natural rate of unemployment. These things are endogenous to the demand side of the economy. Fast demand will generate fast growth. Slow demand will generate slow growth and higher unemployment. Because of the convergence of supply to demand also, if you're somehow looking at something like an output gap or an inflation target to guide your policy, it could be misleading because you're going to get convergence of supply to demand, even if you're well below what the feasible growth path might look like with stronger demand. And so you might get inflation more or less stable because supply is roughly in line with demand, but not be growing nearly as quickly as you could. And lastly, I think what everybody who studies supermultiplier models thinks of when they think about applying this to real-world economic activity is that the empirical and historical study of autonomous demand dynamics are critical to understanding real-world economic growth. And other versions of this talk that I've been happy to give at various places in Brazil, I've actually taken this model and then applied it to U.S. Secular stagnation. I won't have time to do that today, but I think it's a very useful way to think about organizing our more empirical historical analysis of what's actually happening in real world economies. So that's the Cambridge paper and some interpretations, extensions, a few minor ones here. But let's take the time left. And if I understand right, we had about an hour and a half. So we've got some time here, and then leave some time at the end for questions. To some new work that we're doing that focuses on fiscal policy. And so in some ways, this picks up exactly where the previous slide left off. Autonomous demand drives growth. Fiscal policy is critical to autonomous demand. So if we want to think about a more kind of policy-oriented implication of this work, and also generalizing, make it more realistic, modeling government spending and taxes explicitly make a lot of sense. In addition, we want to consider the implications for government debt. And among us heterodox economists, especially if we've got followers of the modern monetary theory here, of which I'm kind of a fellow traveler, it's another discussion altogether. But you might say, well, why do we worry about government debt? There are a lot of arguments that say it really isn't all that significant, but there are, I think, reasonable reasons to think about government debt. One is distributional consequences. Even if we're not going to run into some kind of default issues or tipping points along the lines of Reinhart-Rogoff results or things along those lines, greater amount of government debt implies more government debt service. That's a transfer from taxpayers to bondholders, and that can matter. It's clearly got political relevance. Even if the underlying economics are somewhat flawed, there is a strong, sometimes I will put in air quotes here, common sense view that higher government debt has to be a bad thing. So we should at least be able to talk about the implications of some of these fiscal policies linked with demand-led growth and how they relate to government debt. And also, since I'm talking to my friends in Brazil, recognizing, I'm a very U.S.-focused economist. I apologize for that in many times, but the constraints that most countries face are different on public debt are different from the U.S. Where not only does the U.S. have a sovereign currency, but also has the reserve currency and things along those lines. And I know from talking to some of you that even though Brazil has its own currency, it probably has a sense that the international economic situation implies more constraints on government debt than might be apparent, and so especially to Americans. So I think it's useful, important to think about the effects of government debt in the context of these models. So we're putting government into our model that we just published in the CJE. So we have the same investment dynamic adjustment equations that I talked about before, exactly the same supply side links to unemployment demand growth, no change there whatsoever. But we add these government spending aspects to the model. So now autonomous demand is government spending. I think I'll mention at the end, if I have a few minutes, about some generalizations of this. But in the model that I'll be talking about now, autonomous demand is government spending. It can be government spending on goods and services. It can also be transfers, as long as those transfers are 100% spent. I know there's some discussion in the work that Ricardo Suma and others are doing about having a marginal propensity to consume on transfers. That's, I think, a reasonable thing and can be extended. I don't think it's going to change the results very much. In our case, we think about transfers as being spent. I think in reality, most transfers are spent almost 100%. Public debt dynamics, so the kind of standard equation of motion for the stock of debt, the previous period stock of debt, grossed up by the interest rate plus the government deficit or minus the government surplus if the government's in surplus. And two kinds of taxes on production income at a tax rate tau y, and taxes on interest income. So interest income is for now a given interest rate times the debt ratio, and then a tax rate on that interest income as well. So that's the basic structure. We also have to modify the consumption function to make the taxes explicit. I have a little nod here. I don't generally write my models in the standard kind of stock flow consistent matrices and things like that. But I think that might be wise in the case of this model. Be very simple, but we want to make sure if the government is paying interest on its debt that it goes someplace in a consistent way, and in fact it goes into private income, and private income in the private sector may spend part of that interest income, so after tax. So the consumption function is modified by putting the tax rate here explicitly into so that's after tax income that drives consumption out of production income, expected production income in period T, and also similar specification for interest income. Notice that the debt rate, the debt level is defined beginning of period, so there's no expectation term on the debt here that's known at the beginning of the period. This is actual interest income during period T. Again, with a propensity to save imposed here and a tax rate imposed on this. So that's the entire model. In addition to what I showed you before from the 2020 paper, let's talk about some results. Steady state, no big surprise. Super multiplier results. Growth happens at G star. Now G star is interpreted as the growth rate of government spending. Again, both spending directly on goods and services and transfer payments. There's this key adjustment. I didn't emphasize this so much in the 2020 paper. There's a similar argument there. This is actually something I learned from a comment I gave when I first met Franklin Serrano at a seminar at your university a few years ago. I used to talk about the share of autonomous demand as if it was some kind of an exogenous parameter. And Franklin kind of raised his hand and said, that's not really, he's very polite about it, but you're really wrong about that. And he was right, I was wrong. That is that the share of autonomous demand in the economy is endogenous in a super multiplier model. And here's the equation for it in the medium complicated equation with all this stuff. It's particularly incorporating this possible spending and taxes out of interest makes this a bit more complicated. But the idea here is ultimately pretty simple, but also very powerful and important for fiscal policy, is that the output path is going to adjust to generate convergence of autonomous demand share, or in this case, government spending share, to the steady state level. So that, gamma T, the share of government spending in the economy at any point in time, is going to converge in a stable model to this steady state level. And let's just consider a little bit of the intuition for why this is happening. Let's do a thought experiment where we raise G star. And as you see here, that enters this equation for gamma star with a negative sign. So a higher growth rate means a lower share of autonomous demand, government spending in total output. Well, what's happening here? Well, it's actually pretty straightforward. If you're going to have a higher growth rate, you need the investment share in the economy to rise to increase capital growth. So you have to devote a larger share of output to investment to support a higher growth rate. It's an obvious result in any growth model. Mainstream, Koleskian, super multiplier, they all would get that result. So you have a higher investment share. The consumption share and the tax share are actually driven by behavioral and policy parameters. So the consumption share is ultimately determined by these saving propensities. The tax share is determined by these tax rates, which are policy variables. So there's no, from my point of view, no obvious reason to think of those things as endogenous. I think of them as fixed. My hesitation here is going back to the old Calder point about income distribution adjusting to make the marginal propensity to save consistent with full employment growth. So you could have a Caldorian adjustment here. I've never found that model particularly realistic. I even commented on that way back in my dissertation days. But in any case, that might be a different way to go here. But in a way, the way we're closing this model is by assuming that the saving propensities are given behaviorally. I mean, you can incorporate some distributional effects here, but that the distribution is not endogenous to this adjustment process. So what's the bottom line? Well, the bottom line is if the consumption share is not going to adjust and the tax share is not going to adjust, but the investment share rises, then we have to see the share of autonomous demand, the share of government spending fall. And how does that happen? Well, it happens because when the growth rate rises, the growth rate of demand rises, you move out of steady state, you get faster growth of output until the share of government spending has declined to the new steady state rate. So I believe my next slide here is actually some graphs. I hope you can see them large enough to get the idea. So there's 4 different panels here. The first one, this top one, is the growth rate. So what's actually, I think the title is missing. Does it show up here? There it is. The growth rate is a permanent increase in in autonomous demand growth, government spending growth, from 1.7% to 2.7%. And I picked those numbers because 1.7% is the real geometric growth rate, annualized geometric growth rate in the United States from the peak prior to the Great Recession until whatever until before the COVID crisis. So probably till early 2020. That's relatively stagnant, as I've mentioned. What would go to a number which I think might be much more indicative of the U.S. potential of 2.7%. Frankly, I think it could be even higher than that, but let's just go with that. So a 1 percentage point increase in the underlying demand growth. And what happens, you see the growth rate, it rises. You see it does get above the green dotted line here is the steady state growth rate of 2.7. It jumps above that. So for a while, the economy is growing faster. That's how that share adjusts. So the government spending share goes down, and ultimately you converge slowly. I mean, these are years down here. So you move pretty quickly in the first. The shock happens at year 5 to get a little burn-in period for the steady state, and you're moving up pretty quickly in the first few years. But it takes a good 4 years probably until you hit the new steady state. You overshoot a bit and then come back in. Here's unemployment. So it starts at 4% by assumption. Drops down to a little under 3%. So pretty significant drop. But as a practical matter, the U.S. was able to get to unemployment rates in the middle range here, roughly around where the long run steady state is that we get to in some sense. Here is that share parameter. That's gamma, the actual share of government spending. Again, you see it steady state here. It initially rises. You're initially increasing government spending growth. It takes a while for expectations, capital stock adjustment, et cetera, to catch up, but eventually it peaks and indeed declines. So you go from the initial steady state value down to a lower level. You see here, convergence is very, very slow, and I'll have more to say about that in a minute. I mean, it gets pretty close, but it does go below, and it's going to come back slowly. If I ran this out 200 years, you would see convergence, but that's kind of interesting. I'll have more to say about that in a minute. This last one is just the deviation from the initial steady state path, which of course gets massive. You've raised growth rates by a full percentage point. So over a multi-decade horizon, this has a huge effect on the economy. So those results, those kind of theoretical results, are all more kind of real when you see them in a simulation context like that, to me anyway. And I always like the fact that I can prove my algebra is correct. I'll tell you the truth, it often is not. I had a heck of a time making steady state work in those simulations a few weeks ago, but it's all working now. So I got my algebra right, and I got my MATLAB code right. So let's turn to government debt and see what happens. Well, let me start with what's a very general steady state condition, and this is something I learned a few years ago. In working through some of this with a good friend of mine here in St. Louis, Nick Tompris, who works in the private sector in a financial firm, and we were looking at some policy analysis, and realized that almost regardless of the model you're looking at, just the basic identity of government debt gives this long run steady state relationship for the debt to output ratio. It's basically the government the primary deficit, that is without interest, the primary deficit as a share of output in the numerator, and the growth rate minus the interest rate in the denominator. One small addition to this, which is maybe not so small, that comes from modeling the taxes on interest more explicitly here, is how the tax rate enters this equation, how the tax rate interest enters. And you see it's actually a pretty big deal. These numbers are both relatively small. G star, let me just stay in real terms for now, not get into nominal stuff, but might be 2.5, 3, maybe in a faster growing economy, 4 or 5%. Interest rates, what are they going to be? They're interest rates. So they're real interest rates on government bonds in the U.S. are now very low, actually probably negative in real terms, but historically have been around 1 to 1.5%, although lower since the Great Recession. So this difference is small, and lowering the effective interest rate for this equation by a non-trivial tax rate that might easily be 30%, especially on higher income people. With state and local taxes, could be 40%, even 50%. So that could make a big difference in this debt to GDP ratio. But this is all independent of the model it's going to apply in a neoclassical model, a supply-driven model. I mean, this is just a very general equation. But the key here is that what's different in this model, of course, is G star is driven by the demand side, not some long-run productivity growth, as would be the case in a neoclassical synthesis or a solo growth model or something like that. And there are really two key effects of higher government spending growth on this steady state for the debt output ratio. The first one's a kind of standard and obvious one. That is, you raise the growth rate of the economy because you have stronger demand growth, you're going to lower the debt to GDP ratio. That was straightforward. What is maybe a little more surprising here, but it's partially why I emphasized this so much for a few slides ago, is that there's also effect on gamma star, and it goes the opposite direction of what common sense might suggest. For example, let me make a common sense kind of argument of somebody who, is kind of on board with more or less Keynesian thinking, at least for a medium term. Said, all right, I can buy your story. We have some stagnation. If we were to have a higher rate of government spending growth, you might see some benefits on the debt to GDP ratio because you have a faster growing economy, but you are going to raise the deficit, and that's going to come back to bite you. But actually, in this term, it's not true. That is, the equilibrium steady state result here is that the gamma star falls. The share of government spending in the economy is lower when the growth rate of the economy is higher. So you're getting benefits on the debt, benefits in the sense of a lower debt to GDP ratio, both from the numerator and the denominator in this model. And I've emphasized, here it is. This is that same equation for gamma star, and there's the negative effect of the growth rate on this. And again, why? Because the investment share is going to go up to have a higher growth rate, so the autonomous demand share goes down, unless you have some other compensating adjustment over here. But other things equal, this is the fact. So faster government spending growth raises output growth. It lowers the unemployment rate, it raises potential output, and it lowers the debt to GDP ratio. It's I feel a little bit like I'm making this as a free lunch type of an argument. And that's always a little bit uncomfortable, especially if you're in a more mainstream sense, but it's the basic Keynesian story. Why is this happening? Because it's bringing underutilized resources into use, both in the standard Keynesian way of, lowering unemployment, but in particular here in terms of generating an output growth path that leads to higher supply, that exploiting the endogenous growth of supply to accommodate this higher demand growth path. I mean, that's really what's driving this result, both by getting the higher G star and the lower gamma star. I mean, higher G star and lower gamma star would happen in any demand-led growth model or any super multiplier model. However, you'd have to worry about whether you can really maintain the G star if you haven't incorporated the supply side, at least if you're in a developed economy where constraints on labor ultimately could be binding if growth got too fast. So here's the simulation of this. Let me again just kind of maybe I could just, I'll leave the slides at this side, so mostly works. So this is the debt to GDP ratio. I've calibrated this so it starts about 1. I mean, you could talk about where the U.S. is right now. It might actually be higher than that, given our current primary deficit. But it's a good starting point. The actual ratio is a bit lower than this right now, if you look at debt held by the public. And then you see this monotonic decline. So this is, again, this shock from increase in G star from 1.7 to 2.7%. But there are a few things I want to talk about here, which is, first off, notice that this is a big deal, right? I mean, this is a significant acceleration in economic growth, but by no means kind of out of the range of feasible or plausible. And the drop is basically the debt to GDP ratio drops by almost a factor of 10. I mean, in some ways, this equation is, because of this big, this denominator being rather small, and the numerator too. Actually, these just quantitatively, this is a rather sensitive equation. So small changes in the parameters generate large changes in the result. You see that here of this dropping quite dramatically. But I did actually extend this out beyond the 50-year horizon to the 200-year horizon, because that's what you have to do to get the convergence of the debt to GDP ratio. That's also why that gamma parameter was so slow to adjust, because the steady states kind of all move together. And so the dynamics here are exceptionally slow. And this really is not about the dynamics of the things like the expectation adjustment in the model. I mean, those things are moving relatively, in a relative sense, quicker. I mean, it's still taking years to adjust to steady state. just on the demand side. But mostly it's just that the debt ratio is a very, very slow process. It takes this little calculation, 43 years to get halfway, from the initial shock to halfway to the steady state in this context. So it's not going to move really, really fast, but it is going to move quite significantly. So let's just jump ahead here. Let's talk a little bit about tax cuts. The obvious other kind of Keynesian stimulus policy. It's often thought of roughly symmetrically. You've got a government spending increase or a tax cut, puts more money in people's pockets, especially if it gets spent. You may, have done old balanced budget multipliers or things like this to get some differences. But, as a first approximation, the idea is, well, if we want Keynesian stimulus, we get it either way. In a broad sense, that's true, and at least in terms of direction. But there's some very different qualitative results with tax cuts in this model compared to demand stimulus through higher government spending growth. So by a tax cut, I'm talking about a one-time reduction in a tax rate. It does have a positive effect on the level of demand, but not the long-run growth rate. The transition effect, of course, when growth is affected, but the long-run growth rate is still driven by, of course, G star. Unemployment falls initially. In fact, it falls rather sharply in the calibrated we model have. That does raise supply. When the unemployment level goes down, it raises productivity, labor force growth. And so it brings, in particular, a stronger economy. You don't lose that productivity gain in particular that happens in this context, but it will. So the supply side will accommodate the higher level of output, but not higher long-run growth. Unemployment returns to its initial U star, but on a higher path of output and productivity. And there are two effects on the public debt ratio. In some ways, the similar ones there. Here, it's the tax rate, which is basically a one-for-one effect, right? I mean, it's showing up. Well, it's multiplied by this big denominator, so that's not quite right. But that the taxes are, the derivative of the numerator is one with respect to the tax rate in this case. But the lower tax rate also raises the consumption share and therefore lowers gamma star. But this is less than one for one. I mean, in the interest of time, I'm not going to go through all the algebra here. Especially gets complicated when you start affecting that this D star itself changes in this context, and we'll work that out in the coming paper. I have some long notes of boring algebra to figure all this stuff out. But you will get some effect. You will get some effect from the gamma star as well in this case. But it's going to be less than one for one. So the tax, what I should have said before is higher taxes in this case raise the debt ratio, of course, in this context. There will be some reduction in gamma star, but not enough to offset the increase in taxes. So just to look at the results here, here's a rather large income tax rate cut. Again, I'm adding the U.S. context, adding federal taxes to state and local taxes, using some average tax rates. This needs to be calibrated more carefully, but these numbers seem to be approximately right. In fact, I got some of these numbers from an article in The Economist just a couple of days ago. And so my benchmark number is at 35%. I'm lowering it to 30%. What do you see? Actually, a quite substantial, very quick jump in growth. From 1.7% at its benchmark up to over 5%. But then a quick deterioration. Going back down and coming back to the original 1.7%. Unemployment drops almost to the lower bound, actually, which is zero by assumption here, and then starts coming back up, returning back to the 4% value. Here's the gamma share, the share of government spending, which will eventually get back to the lower steady state value. It has fallen, not dramatically, but it's fallen, as I mentioned. And here's this is a little more interesting here. The percent deviation from the initial steady state path. Initially you get the faster growth and you grow, and this is actually big. I'll have to think about why these may be unreasonably big. Maybe the parameters need some more calibration. It's about a 15% gain, but it is a level effect, and it dies out, unlike the growth effect that we saw in case of raising G star. And the debt to GDP ratio rises. You don't see much of it here in the 50-year horizon. It takes a heck of a long time, but you see, again, quite sensitive. This drop in the tax rate is almost doubling the steady state debt to the GDP ratio. So, if you think that lowering the debt to GDP ratio is a good thing, then this is the growth of government spending is much more effective than cutting taxes in this context. Okay, so this is pretty much it in terms of analytical results. I think I'm supposed to end in about 16 minutes. So let me do some summaries and of some of the things, and I can chat on a long time about this, but I'll try to be a bit brief and maybe pay attention to the chat window here. If you do have some questions, feel free to start them as I see them come in. I'll adjust what kinds of things I'm saying. So just kind of quickly here on policy implications. Of course, demand drives output growth. Supply accommodates demand as long as you're below that minimum unemployment rate. So it makes sense for government spending growth to target long-run G star in such a way to at least approach U-hat. Yes, I know, I'm going to mention this in a minute. It's hard to know what U-hat is, but we want to focus not just on some kind of output gap or even on the unemployment rate itself, but on growth. That is, government spending is important for growth. It needs to expand to generate adequate autonomous demand growth, unless there's some other source of autonomous demand that's taking care of it, which is an interesting historical question. But in the basic story where government spending is the autonomous demand engine, policy needs to be focused on its growth rate, not just its level. Maximum growth implies a lower ratio of public debt to output than the government austerity. Austerity will do the opposite and also create higher unemployment. Any attempt to lower the government share, if you're going to attempt to lower effectively that gamma star by austerity, it's going to fail, because that gamma star is the strongest tractor in a stable super multiplier model. If you try to lower government spending, you're not going to be able to do it. You'll have to lower its growth rate for a while. You'll lower output. You'll end up getting back to the original gamma star, but with higher unemployment and a weaker economy. So this is a strong argument against austerity. The policy challenges, yes, they're pretty significant. That is there's a lot of uncertainty about what that U-hat is, or some maybe different related supply limiting concept. I'd like to generalize behind just a simple unemployment rate. It's hard to know what that is. People have been estimating it in the U.S., the natural rate of unemployment for years and years and years. I often think the natural rate of unemployment is just kind of the average of what it actually was, because the assumption was we converged to some natural rate. I think my own experience, or my own general historical assessment of the United States, is that aside from World War II and maybe a bit in the 1960s and maybe just for a year or two in the late 1990s, that the U.S. economy was very much not supply constrained. A marginal increase in demand growth would lead to increase in output, higher labor productivity, lower unemployment, higher labor force growth. That for the most part, the U.S. has not been demand constrained. That we were probably operating below U-hat, above U-hat, below supply constraints, and could possibly move quite significantly to a faster growth economy if we had policies that got us there in terms of faster autonomous demand growth. The secular stagnation that Larry Summers has resurrected from Alvin Hansen is an important issue. I think it's quite strong evidence of how the U.S. economy has slowed in a kind of secular way since the beginning of the Great Recession, especially because of the loss of the autonomous demand growth that came from housing, borrowing against the house. And so this is a good example of how this kind of logic can apply. And what this means to me is that we need to do policy experiments. We do not want to underestimate the growth potential from demand stimulus. We just need to be thinking much more aggressively and creatively about how to stimulate the demand side from a policy point of view. That said, this is not a justification for wasteful government spending. This is, the phrase in the U.S., which comes from an old presidential campaign, is it does not mean we want to build a bridge to nowhere. We should do things that are useful. There's a lot of arguments, I think, very strong in the U.S. context of need for more infrastructure. We know the whole climate change issue and the need for green energy. There's probably plenty of ways to effectively increase the rate of growth of government spending. But it's not the only approach is spending directly on goods and services. That's part of why I emphasized transfers in the discussions earlier. That if your sense is okay with it, the public projects don't pass the cost benefit test in a more or less conventional sense, then another way to do this would be to have growing transfer payments to people that would spend it. So examples could be you have a universal basic income. That's what a UBI means. and that there's steady real growth of the UBI. You can have a different kind of maybe low wage subsidy, and again have it growing. What you're doing is putting putting money in the hands of people who will spend it, and allowing them to make the allocation choices about what they spend it on in an individualized way, not having government make the call in some sense. So again, I'm not arguing against publicly beneficial government spending, but saying that's not the only way that you could generate strong autonomous demand growth with a policy that targets something like a minimum unemployment rate. And it's a way that you could address inequality with no increase in tax rates or no increase in debt service as a share of the economy, so that this kind of common sense fiscal austerity doesn't really apply. And let me move on to what maybe will be the final challenge, is some research challenges. Final slide, some research challenges. So what needs to be done? I mean, we're working somewhat early stage, although it's moved along a lot in the last couple of weeks as I focused on giving this talk. One thing is multiple sources of autonomous demand. I know all of you who are familiar with the literature on autonomous demand know that there's lots of other things besides government spending that feed into it. Exports is an obvious one. Levon and I have the paper on that. Consumption that's driven on things besides income, especially debt-driven consumption. A little more debate about residential construction and private, I guess, consumer investment there. But again, I think you can make the case, especially in the U.S., a fair amount of that was autonomous in the period, especially before the Great Recession. That should be taken into account. It's a little hard because these things are not all going to grow at the same rate, as Michalis Nikiforos has correctly pointed out. And so, steady states might be a little harder to manage. I just realized, my goodness, I was on the wrong chat window. I was at I was at the private chat rather than live comments. So sorry, there's plenty of questions here. I just realized the new software for me. So I should finish up very quickly and just take some of these questions. Extension of the open economy is important. Nonlinearity I mentioned, and then a strong empirical agenda. I mean, testing the broad implications of the super multiplier models, which many people have been doing. I've got a few listed here. I'm sure I'm missing many. Exploring these empirical, what I'm calling it a bit in quotes here, micro foundations for these parameters that link the supply side to the demand side. In particular, those parameters leaving the level of economic activity to the growth rate of productivity and labor force and the Verdurne's law effect. I mean, there has been a fair amount of study, especially of the Verdurne effect, but we need more. I think it's a first order effect. Identifying autonomous demand dynamics explicitly, new work there. Identifying factors limiting supply. What is driving that U-hat, among other kinds of things. So this is the message. I like the paper a lot. So I appreciate all the comments I see here for the folks there. Thank you. Some just general support. Loving the unapologetic Keynesian at the beginning. Thank you, Renata, for that comment. Let me just go through these in order. My friend Robert Blecker, I mean, we've actually linked this up. This is a great thing about, we're learning we can do things differently. And so I did send the link around to some of my contacts. And Robert says, your productivity growth equation reminds me in part of an early Kaldor. Yes, indeed. Verdurne's law, would have productivity growth be a function of the output growth rather than capital accumulation? Yes, that's right, Robert. That's correct. I mean, in this case, the two are equal, at least in steady state in this model. But you make a good point. We could think about doing that a little bit differently and seeing how that mattered, especially in transition. Daniela Talfani from Colorado State is basic question about autonomous demand. How can it be sustained in the long run? Can there be permanent debt financed consumption? I don't want to get too deeply into that. I actually noticed that Daniela is wrong. Maybe I could come back to that. I think broadly in this model, it can be sustained permanently. I mean, that's part of the point of supply accommodating demand. That is, if the supply part of this is correct, then you can sustain faster growth as long as you have workers to do it. So the key is having enough workers, and in particular, raising their productivity. I see you back in, Norberto. Do you want to add something here?
No, I'm just entering to help you to coordinate this question, the Q&A. I think Fabio is already.
Sorry about the
Fabio will join us as well.
Okay.
So I think you already passed for the first comment. Guilherme, pode colocar o Fábio, por favor? Não, e pode fechar o comentário do Robert também. Acho que já passamos. Sorry about the Portuguese.
Your language. Sorry about the English.
Hi, Steve. Thank you very much.
Yeah, make a comment here that this is my first experience like this, to give an hour and 15-minute talk without seeing anybody's face.
It's very strange.
Kind of strange, but I just
kind of strange. Yes,
along the way. So great to see some smiling faces.
And thank you very much for accepting our invitation to participate in this webinar series. It's really important for us to maintain the contact with researchers outside Brazil in this period of pandemic, which avoids trips and everything else.
Yes,
so many thanks for you for accepting. I hope we can maintain this contact in the future. I have some observations, some comments related to your work, in particular to the supply side part and also to the fiscal policy part of the work. On the supply side, I believe that you obtain a kind of lower rate of growth, lower rate of unemployment, which would be the limit from the supply side to the demand. No?
Right.
And but I think that before this unemployment rate has been reached, we may have some effects on, for instance, wages and prices and income distribution that may have a feedback effect on economic policy and by means of economic policy, an effect on demand.
Right.
And so what I want to emphasize is the possibility of economic policy constraint on demand-led growth, which may be achieved before we have a supply constraint as explicitly supply constraint. This may happen through, depending on the institutional aspects, on the way the political economy of the growth process may have an important influence on how fast we can grow, even before we achieve a supply constraint. In a sense, it's like Lerner once said about suggested the concept of low full employment, in a sense that an employment rate below which we would have some pressure in terms of economic policy or distribution aspects, which may affect the pace of economic growth. So it's important, I believe, in the development of this kind of model to have a connection with variables such as inflation, income distribution, in order to incorporate in the model this kind of possibility of economic policy constraint. Of course, in economies like the Brazilian economy, we have the problem of balance of payments, which is not an issue for the United States as is for the Brazilian economy, because it's a kind of financial constraint to our growth, and also connects with inflation. If we have some effects on exchange rates, nominal exchange rates have a feedback effect on inflation, and so through inflation in economic policy or in terms of reserves. So I believe that this kind of economic policy constraint may have, or this financial constraint related to the balance of payment for the Brazilian economy at least, or developing economies, is very important. On the other hand,
sorry, just to add, because Professor Robert Blacker also posed a question on this. He asks if for a highly open economy, would be a balance of payments constraint could alter the conclusions of fiscal policy. He's asking about Brazil precisely.
Yes, I believe it is the case. I will let Steve. May I continue, or may I Norberto?
I think you can go on, and then Steve answer this first round of questions.
Okay.
Then I take, yeah.
Okay, no, and so there is another important issue. You mentioned it in your last slide, but it's really important, which is the dynamics of autonomous demand composition.
Yes.
When we consider more than one source of autonomous demand and the relationship between them. And one important issue in this aspect is the kind of debt dynamics that is generated when we have different rates of growth of different autonomous demand components. So we may have some debt dynamic process which may be unsustainable, and so can have an effect on the pace of autonomous demand growth. And for instance, one example is the one that Robert is mentioning. If we have a very fast growth of autonomous demand trend, domestic autonomous demand trend, and exports lags behind, we may have problems with external debt. So it may have a feedback effect on the growth of a domestic demand and affect the trend rate of growth of the economy. And I have to mention, I just finished a paper, we'll publish a paper in Review of Canadian Economics with an extension of the supermultiplier model including a government sector and debt dynamics. And I explored in the paper, I don't know if you attended one of the presentations of this paper in Berlin, or I believe also in the United States. But I have two comments on your strong results related to the effect of government expenditures on the equilibrium debt ratio, and also relating to the self-defeating austerity result that follows from your model. When you introduce other components of autonomous demand, these results may not be necessary. They are not necessary results of the model, depending on the dynamics of the other components of demand, of autonomous demand. And also, I would like to point out that you show the results for the equilibrium debt ratio, but there is an important, it's important to emphasize the relevance of the Doma condition related to the stability of the debt to output ratio. And because the dynamics of the debt dynamics change radically when we have the rate of interest above the growth trend rate of growth of output or below it. So the model should be changed, and economic policy implications are different, or may have to be qualified. And I believe it's my last point concerning the tax rate analysis. This is a great opportunity to return to a question and debate we have with you in Rio when you came here for our seminário, and it's related to the way you formalize the equilibrium unemployment rate in your model. I don't know if you remember, but I tried to criticize the way you obtained this unemployment rate as directly related to the rate of growth, in the sense that you don't have any hysteresis effect of the growth rate to the unemployment rate. Because why this is important, I believe so. Because if you have some kind of hysteresis effect, you may have a permanent effect of tax rate or level effects of the supermultiplier model on the unemployment rate. This is, I believe, it's a good way to put to go back to our discussion at the URCA, at the bar at the URCA that we shared. I don't know if you remember it. So it's my point. I finished it.
Good. So maybe I'll just respond. I guess we're a little over time. Is that okay, Norberto?
I was muted. Yeah, no, it's okay, no problem at all. We can go. We still have a couple questions from the chat as well. So we have this first round. Then I think it's 2 questions basically from the chat.
Okay,
And then we
I'll
close.
have to coordinate those. But let me respond to
Yeah.
which, always it's just a pleasure to to have this chance, even though we're separated by 10,000 miles or whatever. It's maybe not quite that far. It would be much more fun to be doing this at the bar in Copacabana and looking at the waves crashing in. It's such a beautiful place. Okay, but enough of that. So let me mention this. So I really, most of the things are very, very well. They're all helpful, and some things we've thought about, some things less so. Let me just kind of comment pretty quickly on the idea that yes, if we think about especially raising the growth rate, and the way this model works is this kind of thing. Okay, you've got this minimum unemployment rate. You could argue that it's a target for the economy, but as you get closer to this, what's going to happen? The first thing I'd say is this is really a strong case for some kind of nonlinearity, so that we're seeing that how these things play out. It's not going to be simply linear. Linear is a good place to start. It's the first approximation to anything, but we need to move beyond that. And I think your point goes in that way, and it does mean we've somewhat not really resisted it, but we haven't emphasized it so much. Picking up things like inflation dynamics, wage dynamics, things along these lines. Another one that comes to mind, some of the criticisms of expansionary fiscal policy, even from the MMT crowd, is that you'll run into bottlenecks and things like that even before you get to true full employment. So we have to target things differently. I think all these things play a role here, and they're relevant, and they have policy implications. And indeed, part of the story, I think, is why have we not experimented more? Well, part of it is thinking that in the end, it's whatever happens is the result of the supply side, and we can't do anything about it. But part of it is the worry about inflation and other kinds of things like that come into play if the unemployment rate gets too low. So you get these these Lerner-Koleskian kind of concerns in this context. The second comment, as my notes indicate here, is linking to balance of payments constraints, and Robert's talking about this and things along those lines. For sure, I know this. Again, I think usually I did a little bit this time. Every time I speak to a non-U.S. audience, I apologize for focusing too much on the U.S. And at some point might get sick of hearing that and say, well, why don't you do something about it? We do need to generalize this. For this to work, even for the U.S., it needs to be generalized to an open economy framework. The balance of payment constraints seems to me entirely sensible, and integrating debt accumulation in this context. Yeah, sure. If you have faster growth, that leads to faster growth in consumption, that leads to more imports. How does that all play out? Is that just going to that's going to add some complexity to the model? Will it fundamentally change the results? To be honest, I just don't know the answer. But it's the right question to be asking. Is it this paper? Is it the next paper? I don't know, but you should be holding my feet to the fire and say, don't show up again in Brazil, too many years without having dealt with this problem. So I take that into account. I will actually take this opportunity again, I think, because I saw his name in the chat. So I'm going to start working together with this remarkable PhD student from Chile, Alejandro Gonzalez Castillo, who will keep me, I think, focused on this and say maybe we need to put imports in there right away and balance of payments or moving maybe parallel in that direction. So I appreciate that. The dynamics of autonomous demand, I think this is really important. I was somewhat late to the whole super multiplier literature, as my early comments indicated, and at first it just seemed to me, in a way, it was too simple, right? It just this one G star drives everything, and I know some of the critics who've been hesitant to approach this especially more of the group that's more on the Koleskian growth side. I think point this out, and with fair justification. The phrase Deus ex machina comes to mind here in terms of what's going on, and I resolve that in various ways. One is my center of gravity argument, which is to say it's not that we're actually going to converge to this steady state, but it's always in the background and helping us understand, real world dynamics of the economy, but also recognizing that we need to kind of empirically, historically, theoretically think about the multiple sources of autonomous demand and how they interact. And here steady states, I'm afraid, are going to elude us. This is my view anyway, because in the long run, if you have let's have 6 components of autonomous demand with different growth rates, we know what's going to happen. The one that has the highest growth rate is going to dominate, and that long run is going to look exactly the same. But who cares about that? I mean, that might be a 100-year result. The key is, it could be, for example, that, I don't know, private autonomous demand driven by debt is growing very quickly, but only for a few years. Government spending growth is smaller, but government spending growth is much larger. And, how that all plays together is I really think it's an empirical and historical question. But at the very least, those of us doing these theoretical models could at least start thinking about that. And one of the things we do with these simulations is not so hard. We can put some different dynamics in there. While we may not get steady state results, we should be able to see, what some transition path looks like. And like you say, are there long periods of time where some of these results that look so sweet in a nice simple steady state model are much more complex? That's a question I can't answer now, but I should be working on that. The Domar condition I entirely agree with. You're right. The U.S. now, and as Blanchard is on this, of course, among other people, the real interest rate of 1.5% was even high before the crisis, or before the Great Recession crisis, and now it looks like it's effectively it's zero, it's negative literally right now in terms of real interest rate. There's also some interesting nominal interactions on this. I don't want to get into too much detail here, but the U.S. tax system is such that nominal interest is taxed. So if you look at the denominator of that steady state rate, that tax rate starts to be a big deal, because it would kind of be the nominal growth rate of the economy minus the after-tax nominal interest rate. So in some ways, the chances the Domar condition are satisfied, or that denominator is positive, is pretty high. But I realize, again, this is a U.S. perspective, and that government debt in much of the rest of the world is a different story. At the very least, that should be recognized, right? That should be part of the discussion. So you take that, and I apologize that the discussion where I probably only drank 1 or 2 beers, but at that bar you mentioned where we had the conversation, but I'm a lightweight, and so it doesn't take much. And so I probably didn't go back to my room and immediately write notes down about history and unemployment, but now you reminded me when I'm totally sober. And as a result, I've got it in the notes here, and we want to explore that. In fact, I'd like to talk with you more about it, because I think it's what you have in mind. And I take your point that if you start building in those hysteresis effects, that these things that look like level effects in the simple are going to start to spill over to what is feasible on the growth side. So, to
business.
This way. So, Roberto, a couple other questions maybe before we wrap up?
Yeah, I will just I'll make 2 groups of questions. One is from Rodrigo Magalhães. He asks, what assures that this endogenous demand-driven technical progress of labor productivity does not result in a final decrease in the demand for labor? And then he develops this due to a high Verdun's effect on the labor coefficient. He's thinking of something in line of the Nesta, Storm productivity regime. And also Lucas make a follow-up comment on this, saying that you must have an implicit hypothesis that all productivity gains go to real wage increases. Otherwise, the wage share will reduce and the supermultiplier changes over time. He says that it would be hard to keep this hypothesis in the case of high unemployment rate. And the second group of questions, comments, I will start again with Daniele Cavani, who left us to the bike parade, but I think he can watch this later. And he just have this question about autonomous demand. How can it be sustained in the long run? Can there be permanent debt-financed consumption, or permanent exports, net exports, positive net exports, or a positive or a deficit, cumulative deficit? And also Kyle, I think he makes a question which plugs into this. He asks you for developing a bit more about the effects of endogenous financial stability, just as we saw this on the international crisis in 2008, how this can be plugged into the system of equations and what you're proposing here.
Oh, okay. So those are all good questions, and you're making me work. This is there's basically all of macroeconomics here in some respects, I think. But good. I mean, let's have that conversation. I started to respond to Daniela's question earlier. He may have some other things in mind, and he's not with us yet at this point. So, I mean, in a sense, can this be permanently sustained? As I point out, the key here is linking the supply and demand sides. So in this simple model, yes, it can be permanently sustained. Now, what are the qualifications to that? Well, first off, is that ultimately there's still going to be the resource limitation, and some of the points Fabio mentions about what happens as you approach that, how high can it be sustained, what's going to happen, maybe policy responds endogenously. So you can imagine lots of different structural things that would at least change what is sustainable. I mean, ultimately, I guess in a very simple way, maybe a fair way to respond to Daniele is to suggest that, okay, you have this kind of two regimes in the simple model. One is you're below that, you're below the supply constraint, your unemployment rate's above the minimum, and then a marginal increase in the growth rate can be sustained. And in the case when you cross that bridge, that it can't be. So in some ways, the key here is to generalize that discussion. And again, because he mentioned some of the other kinds of constraints, balance of payments issues, imports, exports become central to that. And I've already basically said, look, I can't really go there yet and see how these things interact, but I think that's a worthwhile generalization. On the questions about the wage share, that's a good question. So, something unusual. There is anybody who's known me and seen a number of my presentations, knows that I have a kind of tendency to march to my own drummer. So, I was doing these things literally around 1980, I think, when I really started. I started my graduate study in 1978, and kind of voice crying in the wilderness out there and finding my own way on this. And so it's a bit unusual in this context not to have profits, not to have wages, not to have explicit distribution in these models. At least one person in the work in this literature, I won't, probably wouldn't mind me using the name, but I won't say, well, maybe it's a little bit different. It's a little refreshing. Not always about, wage-led growth, profit-led growth, et cetera, and so forth. But, I recognize that distributional consequences are important. I suppose the simple story here is that the model is distributionally neutral. So in some ways it profits, wages, whatever, it doesn't matter. But that's too simple of a response. I think there's a good point here. In fact, there's at least a beginning of a distributional aspect of this with this interest different from the production income, because you'd expect those things to differ. You'd expect the savings rates to differ because of distributional consequences there. And so another extension of the model, quite sensible extension of the model, would be to build in some more distributional things, in which case I entirely agree that you'd have to deal with what is, where does productivity growth go? Is it just kind of to get some exogenous parameter that splits it up evenly, or do we have some kind of more endogenous or time-changing dynamic? I know in the U.S. context, you have these, broadly speaking, two regimes, one of which where growth was pretty broadly shared in the post-World War II decades, where income distribution growth didn't change all that dramatically, and then shifting sometime in the 1970s or early 1980s, you have where the vast majority of growth is going to the top part of the income distribution. And how is that playing out? That's actually, as I say it, a really interesting question to ask in this context about how that plays out. And so the last one is the financial instability. So I guess this gives me a chance for anybody that's stuck with me now from an hour and 45 minutes, but to go back to the beginning. So, what, Fazzari, did you do between 1984 and 2013? Were you asleep? And no, I actually was working a lot on financial stuff and financial instability, and that's another story for a nice outdoor bar at Copacabana when we get back there in terms of what was happening. But the bottom line is, financial instability is really, really important. There's a kind of sense in which this research program has moved somewhat independently of that. I mean, if I go back to the work that Ferry and Greenberg and I have done over the years, we did do a number of papers on Minskian instability and things but there was this shift where we said we want to focus a little bit more on the demand-led growth question, and we haven't kind of pulled these things together. I think that's a very worthwhile objective. It reminds me a little bit of the physicists trying to integrate general theory of relativity with quantum mechanics. And for anybody that likes to watch pop science shows late at night like me, you realize that's really hard. So I'm a little daunted in terms of pulling this together, but I think this goes again to something Fabio said. One at least starting point for this is thinking about these different sources of autonomous demand.
Yes.
So if you have especially debt-driven consumption, and I interpret a lot of the debt-driven consumption of the U.S. economy from the middle 1980s until 2006-7 as autonomous demand, and thinking that this is, but it's also in some ways became unsustainable because of the debt, the financial instability aspect. So the Minskian kind of unsustainability is working there. And again, the kind of long run steady states don't quite get us there in this context. We need somewhat of a different framework. Is it purely a simulation framework or something like that? I don't know the answer, but this is a good objective.
I agree.
Well, I'd like to thank you. Sorry, I think someone is with the YouTube. Okay, that's okay now. No, we're having some echo. Don't know why. But well, Fazzari, thank you very much for this presentation. I think you must be tired now because but it flowed very well.
It's really 2 hours earlier, so it's lunchtime, right?
Yeah, sorry about that.
You're hungry, not tired.
Well, but we are coming to an end. I'd like to thank you. I'd like to thank you, Fabio, as well, for joining us. I'd like to thank Guilherme for the support in our streaming and YouTube, Camila for the beautiful artwork and for the social media management. And just about the next webinars, as many of our students asked for a presentation on the current economic debate in Brazil, in the next webinar, in the 3rd of July, so 2 weeks from now, we will have Professor Laura Carvalho from the State University of São Paulo, and she will be presenting her brand new book called Curto Circuito. And then we'll have Professor Fiona Tregena in July 17, and Professor Robert Blacker in the end of July. But I will inform you better in the following weeks, but it's more or less our schedule for the next month. So thank you again and see you soon. Bye-bye. If you want to say a final word, Fabio, please.
I would like also to thank Steve for being so kindly giving his time in lunchtime to us, and I hope we will maintain this contact with you, which is very rich and very and also always very suggestive of new results, and I believe it's we have a good way to interact with our research in Brazil. It's really nice. Thank you very much.
Well, you're welcome, and thank you too for your comments and kind of handling the technology. This worked out really very smoothly once we got it all set up.
Yes.
I've done a couple of talks, but nothing quite this significant and formal before this with the Zoom approach, and I'm glad it works. It's great to bring in people like Robert and Daniela and other people into the discussion from around the world. It's something we ought to pursue more. But boy, I sure look forward to be back in Brazil. I kept that week open in July for a long time, even though I knew it was pretty unlikely to work in many respects. And you have a wonderful group there. Some of the most interesting work in heterodox post-Keynesian economics is happening in that part of the country, and it's been a great opportunity in the last few years to make more of a connection. And I very, very much look forward to being able to get together in person on this continent, your continent, wherever the continents may be. So,
hope next year. Who knows?
Everybody stay well. Wear your mask when you're going outside. Don't listen to Donald Trump or Jair Bolsonaro. I should be careful about these kinds of things. The way things are going.
Thank you. Thank you very much.
Thank you. Bye-bye, guys. Well, see you later in the next webinar. Bye.
Bye-bye.